Hi, welcome. In this video, we are going to look at lists. So remember, we are working with the data structures in Python, and as we said, data structures are the most important elements in any programming language for you to master, whether in C++ or Java. You need to start with data structures. So let's just dive straight away and look at lists. Remember, we looked at strings and numbers. If you haven't seen them, you can go back and check. And let's move on with our journey with Python. Okay, so let's create a list. So I'll just give it a name, my list equal to. So if I just put this like this, for example, and then I check on the type, we print the type of my list. And then remember, you could either right click here and run it or up here. So let me just run it here. So what do I get? It tells me that the type is a list. So just with this is an empty list though. So this is already a list. So now I can put in my numbers or strings because the list can contain numbers. It can contain even strings. It can contain just, it's a list. It can contain just any kind of object. So I could put my B there. I could put even a boolean, true, false, true. Yes, I could put true there. I could even add another list in the list. So let me just say I put say 7 and 8 here. Then let's check if everything is okay. Let's run this. See, so when we run this, you see it's still a list. So the list could have the numbers, could have strings, could have boolean, could have even another list in a list. Okay, so now let us see. So let's try to access values. Remember, that's one of the first things we always want to do, to try to see if we can index, get values from our list or strings or, or numbers or any of our sets, whatever data structure. We always try to see how can we access it. So let me just print my list here, type my list here. Then I'm going to say, okay, how do we get access, say this A? Remember, Python is a zero index programming language. So unlike R, you would have said 1, 2, 3, 4, and you were going to put 4 here if it was in R, for example. But with Python, for example, it starts with 0, 1, 2, 3. So to get this A, what you need to put there is 3 instead. Let's run it and let's see. So you see we get A. So let's say we want to get B, of course, it means we can put 4 there. We put in 4, we run it, and then we get our B. So let's just say, for example, we want to get this last element. Remember, you have the option of either doing 0, 1, 2, 3, 4, 5, 6, or just doing -1. So let's say, for example, you do 6 and you run it. That's, you see, you get the list, which is the last number, which is the last in this list. Then you do -1 again, which is like the last element in the this list here. It will still give you the same thing. Let's run it. You see, you still get that. And then, okay, one interesting thing is you might want to get now this now becomes another list, a new list, which you might want to get the first element of this list. So you can come here and add, say, a 0 here, and then you run it. You see, you're going to get the first element of that list, which is inside this list. So you could now even get the second element. You just take this one from 0 to 1, and then let's run it. Let's run it there. So you see now you get 8, which is now the second element in this list, which is part of this whole big list. Yeah. So okay, so now you just, let's say if we wanted to get remember, just to get, say, this A to B, for example, remember it has to be 0, 1, 2, then you start with 3, then it's supposed to be 4, but then you put 5 because this is inclusive and the last one is not inclusive. So let's just do it. Let's just do 3, and then instead of ending here with 4, which would have been 0, 1, 2, 3, 4, if you put 4 here, for example, you only get A. So Python counts just like, let's just say n-1. So we have to put 5 here for it to count 3 and 4, and it stops before 5. So let's run it and see. You run it, you see, you get A, B. So as just that's correct. Okay, so we are good with indexing and slicing. Now let's see how could we change, say, this value, because this is a value in the list. How could we change this value number 6, number 7 though, but yeah, in indexing it was 6. How can we change this to maybe false, for example? So let's just do that. So we can come and say my list. Now that value, which it was 6, I guess, 0, 1, 2, 3, 4, 5, 6. Yes, that value 6 should become, instead, let's say false. So now let's print our list. Print my list. And then what do we get there? Let's run it. So good. So we have 1, 2, 3, A, B, then now we have 4. So you see, that's how you could easily change a value in a list. So let's say, for example, we want to change, say, this one to maybe 80. So we just need to put, for example, 0 there. And then we say now you're 80, you're no longer 1, you're now 80. Then we print and see. So let's print it, let's run it. So you see we have 80, 2, 3, 4, fine. So that's good. That's now you're able to change values in a list. Okay, now let's look at the mutability aspect. So let us look at something which is peculiar with lists. So now if we have this my list 1, then we have now say my list 2. We create another list and then we assign the list. We say this list is equal to my list, like this. Okay, then instead on this list 2 now, this my list 2, we decide to change that say that seed element to false here. Okay, let's just change it to false. Now we are going to print my list 2 and see. So let's print my list 2 and see. So when we run it, you see it's good. We have the 1, 2, 3, 4, true, false. So my list is having this 7, 8 at the end. My list 2 is having false at the end. But what if, for example, we print my list instead and see, just to check? What do we get? Let's run it. So when we run it, you see my list, yes, is instead moved now from this 7, 8 to false. So it is like they are tied together. So that is an aspect, some characteristics you have to understand, the mutability. So as you copy, as you said, my list 2 is equal to my list. My list 2 is keeps changing each time you change something in um, my list. So let me just say, for example, we do not want this to happen. So we have the option of either saying my list 2 is a list, like this. So it is now, if we run this, you see, let's just run my list 1 and my list 2 so that we can do the comparison right here. So let's run this and see. So up will be my list 1, up will be my list 2. Let's run it. So you see now, when you do it like this, you are able to prevent it from changing. So it's like you've created a new list independent of this my list is completely becomes independent of this first my list here. So another way of doing it, which most of the time you see most people doing, is now to bring in a method, which is what we were to talk about next. So let's just remove this and see. So a method is usually what you it comes after, while a function is usually say what comes before, like this. For example, the length of my list, what is it? But then a method is usually peculiar now to the object. So this list can copy, but an integer or number that we saw before could not do the dot copy, could not do this list of things that you see here. So when you do the dot, you see that it could pop, it can count, it can index, it can append, it can extend, it can insert, it can remove. So you see that these are options that a list can take. Methods that the list is like what the list can do is like an object. That's when you talk about object-oriented programming. Okay, so let's move on not to complicate things. So a method we use here is dot copy. So dot copy, when we use dot copy, it's just like what we just did with the list here. It makes this my list 2 to be independent of this my list 1. So whenever we do any changes, it will not affect my list 1. So for example, if we do again our my list, say my list, then we say my list, put in, give it, say, let's just use another method, my list, or let's go with what we already know. My list, say 0, the first element should be maybe 80. So when we do that and we print our my list 1 or my list 2, for example, let's print them, my list 1, and then we print here my list 2, we print the two of them, and let's run them. So you see here now that the 80 here has only changed on my list 2, but has not changed on my list 1. So with this dot copy or list in front as the list as a function, or dot copy as a method, you're able to separate the two of them from being tied to each other. Okay, that's fine. So let's move on to explore other methods. And remember, you're not supposed to master all these methods. You're just supposed to remember that you can always come and do help. Let's say you forgot and you said my list, I don't remember what dot copy used to do. So you can do my list dot copy. Then when you run this, you see you get this long documentation here. And if you do object-oriented programming, you would understand lots of this stuffs up here. Okay, so but then let's come down to copy. Let's come down here, and then if you see copy here, it just reminds you, I just pass copy, it reminds you that returns a shallow copy of the list. Clear to remove all items from the list. So if we did my list dot clear here, we expect all the items here to disappear. So that's just, you don't need to master all of these. You just need to remember that you could use help or use Google to continue to help you out. But then let's move on with other interesting methods that are good to know for a list. The rest we expect you to learn as you go along. So it's good to know about my list dot append. I'm just going to click here, my list dot append. So let's say we want to append something like, let's just say Z, for example. Then we print my list. So let's see what that gives us. Now let's right click here and run. So you see my list now has Z at the end. So it's append is like you add at the end. So you just at times you'll be using this, especially when you're using for loops in future. Append dot append dot append. No problem with that. So let's move on now. Another thing you just need to know, which is mostly used, is my list dot pop. Remember, we're not going to go through all these. Let's just do it up here. We'll print my list down here. We are not going to master all these methods, just for you to remember that you always check them on your own. So my list.pop, this is the list. Now we're saying my list.pop. So let's see what that gives us. Let's run it. And you see here, so you see it has popped out this 7, 8, the last one here. So let's do it again and run it again and see. You see it pops out this last one here, and then it just takes from, so pop my list.pop takes the dot pop takes away the last element from the list. Okay, good. So you have something like maybe my list dot reverse. Say you just is self-explanatory, you want to reverse the list. So instead of it going this way, it goes the other way. So let's run it and see. So if you run it here, you see now instead the 7, 8, which was here, now is in front, and the other one goes behind. So you could also look at my list dot sort. So let's run that. So it can't sort it now because we have these other elements here. So it is very logical. How would it sort these when these elements are there? So let's say, for example, we took this out like this, for example, and then we did maybe 7 there or something like that. Now let's look at it. If we run that our mylist.sort, you see it's able to sort that order, and then let's just say you had maybe 10 here, for example, 10, and then maybe 6, for example. Let's run it again. You see, let's run. You see, it sorts it in order for you. So you just these methods. You don't need to master them again. You just need to learn to know how to Google them or how to use help. And with this, you'll be able to master how to work with lists. So thank you. If you love the video, share, like, and see you next video.